We're on the last part of problem 4 in Novice Workbook Mod 7. And again, we're looking at optimization. And in this piece, what we're going to do is we're simply going to look at the last question, which is use parameter functions in the analytic solver platform to vary the value of revenue for the type 4 project. Let the lower limit be 50% of the base, upper limit be 150% of the base, and show the values of the objective function and how they're affected by these changes. So essentially what we're going to do is we're going to take this cell, we're going to say it's no longer 1900. It is 50% of that, which is equal to $97.50, and then we're going to take 150% of that, and that's equal to 29,250. Remember these numbers. We're going to use these numbers when we create a special function, sensitivity function here in with the analytic solver program. So what we want to see is how changes occur in the solution when these revenues change. Remember, we asked the question of what the reduced cost was before, and we determined that a $2,500 increase in the objective function to 22,000 would lead us to a solution where we would have some of project 4 before. So we're kind of testing that idea by creating a table of values that say, as you increase revenue for project 4, this is what happens to the objective function. So how do we do that? Well, the first thing you need to do is you need to grab that worksheet that is in the workbook, and I've already done it here, but what you do in the worksheet is you grab it, you copy it, you go outside this workbook, you create a new workbook, and you paste it. As I told you before, the analytic solver program does not like it when you have multiple optimizations going on in one workbook. So we have to separate this thing out, and then we can cut and paste and put the information back into the sheet into the workbook as we need it. So I'm going to get rid of this because I already had one open. So here's our sheet that we're looking at, and what we're going to do is we're going to copy the we're going to enter the information related to our problem into solver. We've got solver set up already with our particular problem. We have to have that done now. So when you copy it, make sure you copy when that you've already done the particular solution, the simplex method solution to this problem. Okay. So I've got that in place, and now what I'm going to do is I'm going to place my cursor here on that cell of interest. I'm going to go to Analytic Solver Platform. I'm going to go to Parameters, and I'm going to go to Optimization this time. Before I went to Sensitivity when I was building models. Here I go to Optimization, and it says, all right, I'm going to give you a function in there called PSI OPT param. What's the lowest value there? Well, we said it was 9750, I believe. The upper value, 29,250, and the base, 19,500. I hit OK, and now if you look at this function in this cell, there's our function. It's assumed the value, the lowest value of the base, 9750, but it's just kind of holding a place there for it. So how do we perform this analysis where we say, all right, vary this value from 9750 all the way up to 29,250, and then tell me how the objective function changes as you do that. So create a table that pairs up values of revenue for project 4 and the outcome associated with the objective function. Go back to Analytic Solver Program, go to Reports, Optimization, Parameter Analysis, and here the program knows that our variable of interest is or cell results is P8, which is the cell associated with the objective function, and then the parameters, if I close this up, I can open it up. The parameter is N7. It's already in there. N7 is what? Well, N7 is this cell where we've got all of those changes taking place. I hit OK. So I need a results cell and a parameter cell, and this pairs up the results and the changes in the parameter. I hit OK. It returns a sheet like this called Analysis Report. This is our analysis report, and then here are our values. I can copy these and paste them. Let's not do that yet, but let's just look at what happened here. Here is the value of the coefficient for the project type 4 at 9750. Notice that what happens is that the objective function does not change. I increase it a little bit, the objective function does not change. Increase it again, does not change. Again, until I finally get here where I go to 23,400 and we begin to see a change in the objective function. Why? Well, because we had not had any of project 4 prior to this point. Our value was 19,500, and this is the value we had. And we said if we add 2,200 or 2,500 to 19,500, which would give us 22,000, there is a change. 22,000 occurs someplace in here, so that's someplace in here is where the change occurred. But the first place we see it, because of the increment of 20,400 here, is at this point. So that's the answer to that question. We paste in the table here, and we see that someplace between 21,450 and 22,425. I have a larger array of values. I had 11 before, but here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got many. It doesn't really matter. We still haven't captured it. I might be able to arrange it so where the incremental change does hit at 22,000, and that's where you jump off from 3,565,000 into larger numbers. So someplace in here between 21,450 and 22,425 is where our change occurs, and project 4 enters the solution. That's the end of part 3, problem 4, mod 7.